then you have Tom.
Okay, we are live.
Okay, I have a whole mess of things that I can try to demo. It may end up being a interactive debugging session because I definitely broke like 8 things within the last half hour while I was trying to see if these things piece together. But that might be just as interesting if it doesn't work. But so, all right, let me share many things. Go here. All right, so I started sketching this stuff out just to even keep it straight in my brain. What I have to show here is kind of like an evolution or iteration on kind of pieces that I've shown in the past. And part of the reason why I barely even remember what I had the last time that I showed some of the stuff because it was like so long ago. And it's all been built over, I don't know, multiple years now. Is that how long I've been working on some of these pieces? And very few hours. So every time I pick it back up, I'm like, what was I even thinking when I was working on this last time? So this has taken a very long time and it's kind of haphazard, but I think it all connects together now. So it should be interesting. Okay, so if you recall, I was talking about this thing called YaRG API a very long time ago, which is basically a web service for interacting with a rover or robot of some kind. And by web service, I mean it just sort of presents itself over the web as an API, and you can post things to it or read things out of it to get information about what the rover's doing. And it's just sort of based on web technologies. So that's what this YaRG API thing in here was for. In the previous incarnation, I was sort of struggling with what should live inside of this piece of software. Like, what about it is general for all rovers or for all robots, or for, and how much should be like a component. And so I had kind of, I think the design at that time was, it was sort of set up to where it could call out to other scripts. So you could write, for example, I think the example that I had was the camera that was, what was that camera? This thing, I always keep forgetting what they're called. But it runs.
Oak D.
Yeah, the Oak D. The Oak D Lite, I think, is what that is. It runs, like you, when you interact with it, you like write Python, and you can even run like a HTTP server on it to like issue a, get a video feed off of it and that kind of stuff. And so but it's all very like in their ecosystem. So if you're going to write stuff that interacts with the camera, you kind of want to write this Python script. And so it won't necessarily interact with whatever else you're building super well unless you've kind of got some standards or a system set up for that. So the way the YaRG API stuff handled that case was it would call out to just like any executable on the system and run that and then interact based on like input and output that came over when it ran that program. I think I found that to be a little bit cumbersome and a little bit difficult to like configure or explain to people how it worked. So the new kind of iteration of how this works is that the YaRG API doesn't do very much except provide this middleware layer where you can interact, all these individual small programs can interact over well, I call it streams. So they can send data in and they can get data out and they can just name it whatever they want. I believe that's pretty close to how ROS works. However, it's very like kind of streamlined and less opinionated, but we'll kind of see. So here in this diagram, I've got these are all different components that you could imagine writing in Python or in whatever you want. and I've got some examples of them to show. But like what I was talking about was like the camera could just send data to the API, and then something else, for example, might want to read that camera data and do something with it. The most direct one that I have is like motor control might be saying like, okay, please make this motor go this speed. And then it's going to reply back to somewhere else that like, hey, here's my current motor speed, or other sensor data that's built into the motor, or whatever. So that all works, and I can show some of those pieces how they fit together. However, well, yeah, I'll show that. Let's see here. So this is, yeah, so this is right one. So this is running on my laptop. And so there's a web server running here, and you can see a bunch of traffic because it's actually interacting with this rover that I have on my desk. But you can see I've got like these command line tools you can use. So if you imagine you had a stream that was called test. Can you guys see this? Do I need to make it bigger?
Yeah, you can see it.
Okay, cool.
I hope the recording sees it, so.
Maybe you can make it a little bigger.
Let's see. Oh, that's the wrong way.
Yeah.
Maybe that's a little better. Okay. Well, yeah, ignore that for now. Okay, so this over here is sub, and if I do YaRG API hub test, I can do something like hello world. Oh. And that just use the YaRG API to like send data from one process to the other process using these command line tools. Okay, so not very interesting necessarily from the command line, but if you write a, so one of the things that used to live inside the YaRG API was the logic that converted my sort of language for describing the movements, like move forward 100 or right turn 15 degrees or something like that. It was like this, simple text-based language, and it converted those into the motor commands, like engage this motor, this speed, this other motor, this other speed, to enact those commands, and then like turn it off after a certain amount of time. So I ripped that all out of YaRG API, and now it's just a Python script. You can see here, written in Python, like if you were to say left turn, it's turning one motor backwards and the other motor forwards, and then after a certain amount of time, so it generates a delay that sort of like calculates how long that it should engage those motors, and then after that delay, so it sleeps for a little bit of time, and then it tells both the motors to stop. And so the way this works now is that we just subscribe to a stream called CI, which is called command injection, and then we're publishing up here, we're publishing to two channels called motor A and motor B.
Publishing means sending out of the rover?
It means sending it to YaRG API. And then if someone else is listening for it, it'll be able to send it. So I'm going to turn off this actual rover here. We can kind of test this by, I think this is actually running. Okay, so this is that CI program running all by itself. All it did was it subscribed to the stream CI. If I come back over here, we could publish something to CI, but it has to look like this. Ping. So if I do this now, nothing should happen because nobody's listening for it. If I came over here, let's do sub motor A. Okay, so the idea was that we wanted. So oh yeah, this did receive the ping, but what I actually want to do is do something that engages the motor. So I'll say forward 100.
100.
And you can see this the motor channel turned on 1 and then it turned off to 0. So this
where are these things running? So you've got two streams, one sort of like publishing requests and the other executing them. So one is running in the web browser and the other is running in the robot. Is that it?
Well, for this example right here, they're all running on my laptop all on the command line. So I've got like the server running over here. That's just running. I turned off my actual rover, so it's not doing anything anymore.
Okay,
so nothing's happening there. This is all on my laptop. This thing is running on my laptop, and it's subscribed to the CI feed, I've also got the subscription for the motor over here.
Can you say a little bit more about how streams work? Are they like communicating processes in the Unix shell, basically, or what is a?
Yes, and that's sort of where, like, originally I thought, well, Unix or Linux will be my robot operating system, and we can simply have programs that like stream to other programs using the normal Linux things. But that started to just become a little bit awkward for some programs to be able to write that way. So all this does is provide kind of a network service that's running on the rover. In this case, it's running on my laptop that facilitates that communication between the different programs. It also has some extra stuff that the API is doing that, like, some of the streams are special, that it can kind of like expose stuff, and I'll get to some of that. But it's at this stage, what I've shown is like all it's doing is like facilitating that inter-process communication by giving a name to something. Does that make sense?
Is it via sockets?
It is via sockets, yeah. Not named sockets on a file system or anything. It's just like it connects to a via HTTP. So this is actually, I'll show you the.
That's why you call it publish.
Yeah, it's the publish is literally like posting to a web endpoint. So you can do this with curl. You can do this with anything that can write an HTTP client. And I put some examples in here in this README. This is the README for the repo up here. But so you can see, like, this is all it takes to post to a stream is with like the curl command line, which is a very kind of common tool for that. But like, you know, any operating system, anything ought to be able to like post to this endpoint.
So it's more or less like what I had, right, for DevCon. So I had
Yes.
a server with endpoints.
Yeah. So okay, so that's publishing and subscribing. You can do it like on the command line using like the built-in tools that we've got, or you can do just curl. Like, it's very, very like easy. And so it's such a straightforward protocol that I actually have client libraries that were very easy to write that make it slightly easier for the program. Like, you can do it in Go, of course. There's a Python API for it, and I've actually got a version that runs in the ESP IDF environment. So, you know, it's all written in C using the ESP HTTP clients, which is what I've got running on my rover, which I'll get to. But anyway, that's just talking about how all of these pieces interact with this, right? So all this everything inside this is on your rover, or it's at least part of your rover neural system, like wherever it might run across multiple computers, I suppose, but it's sort of this is the software that makes up your rover. Does that make sense?
How's any of this affected by the amount of processing or type of processor we have in the rover? In other words, if I had one of these new Google 1 million qubit processors, would I do it differently?
Well, I can give a more concrete example. Might be this rover here is just a ESP32. Like it doesn't have, it's, just an Espresso chip. It is not a full like Raspberry Pi or something, right? It doesn't have like an operating system and that kind of stuff. So I'm not running this entire ecosystem on that chip because it's just too much stuff and it just wouldn't be quite appropriate for that. So what I've done for this particular example is I'm running basically only, I'm running right now, it's basically the motor control and the camera and any sensors that I want. And that's one software package that's written in C. So that runs natively in the environment that you get for this embedded system. It runs there and then it communicates with the YaRG API over the network because the ESP32 has Wi-Fi, so it can communicate over Wi-Fi to a YaRG API server that I've dedicated to the purpose of like providing the intelligence for the rover. That could take the form of like a Raspberry Pi that rides on top of this rover along with it, and it communicates over a different way too, or it could be just something on the local network. This is pretty similar to, I forget exactly what all the components were called, but for Anuraj's stack, like you've got the rovers that move around, and then you've got to have a computer somewhere that's going to offer the kind of communication bounce to the outside world.
So basically, like you don't need the computer because the computer server was basically a frame server for payment or the token gating. But the endpoints were directly running on the rover on the ESP32 for the moment. So if you are on the local network or basically if you have those endpoints, you could directly control them. But
right. And so for
server was needed. Yeah.
For this, the communication pathways are kind of flipped around. So instead of trying to get the requests to the rover, like literally trying to find the IP address for the rover and sending it to the rover has been configured with the location of the YaRG API server, so it can subscribe to commands or sensor data or whatever it's supposed to get from YaRG API, and then it just like waits for something to do.
But this YaRG API has to run on every rover then?
Yes.
Okay.
Yeah. Okay. So the other component here that so like everything in this box you can consider the rover. It may or may not run on the actual, like what chip it runs on, like is unclear, but that's the rover. I've got this other piece that's called YaRG GDS, that's ground data system. I think I've demoed this before, but this came about as part of our original Yakosaur plan, which was to have, drop a rover off in the desert somewhere and be able to communicate with it in a very slow, methodical way, right? Like I was playing with the Blues wireless component to offer like cell communication with that rover, right? And so the idea was like you're not, any sort of remote control that you're doing is going to be kind of slow, and you don't have like real direct, you don't have like joystick access because you're operating over this kind of slow wireless network. So this is YaRG GDS, which it acts kind of funny in these kind of examples because the original idea was this is going to live, where'd my diagram go? This is going to live somewhere on the internet, and it can be a control system for many different rovers. So actually it's got different missions that I've used for the first mission was over a year ago. I did this one that was escape the garage, and so I've got like a sequence of images here that was like the first little bit of this rover crawling around out in the gravel, which I think I demoed that before. So the idea though is that this thing lives on the more publicish. It's like more like a public interface for rover control, and then the YaRG API server, the rover itself, is also kind of reverse of how the other stack is, where it's like the rover is actually trying to communicate with the YaRG GDS to try to pull down commands that it's supposed to run. So if I ran, where to go? So if I go back over here to my garage demo, so if I do like forward 100, it generates this command, and this is like, it says pending, because it's just sitting here on the data system waiting to get pulled in by somebody that's listening for it. And so you can see it disappeared because it finally got pulled in. So it means that it's kind of slow because there's this pulling kind of interval where the rover itself has to eventually connect and pick up the commands it's supposed to run. That simulates that same idea of like, well, if this is running over a cell phone and it's dropped in the desert, maybe we only pick up every hour to see if there's anything new for it to do, because running that cell modem is expensive.
Yeah, but that is a good idea, right? But so the rover only does something when it wants to, right? Like
Yes, so it chooses when it has the power or when it has whatever to like pull down new commands. And it's also choosing, so this is like the telemetry data that's being posted back, and it can choose when it has enough information to post back up. So it can say, okay, I'm going to fire up the cell phone modem and I'm going to send out this new information.
So in your block diagram, you had one-way arrows pointing from web browser to YaRG GDS and YaRG API to YaRG GDS. There's no arrows going out. So what do you mean the rover pulls the command from YaRG GDS?
Yeah, so this arrow right here is trying to indicate that YaRG API has a process internal to itself. It's going to say, okay, I'm going to wake up and I'm going to look for new commands that's available on the YaRG GDS server. And so it issues a HTTP request to this server, says, got anything new for me? Cool. It also does the same thing for sending telemetry. It'll just say like, well, I'm going to post new telemetry data to this YaRG GDS server that's up here.
Okay.
Do you have the YaRG API running on the ESP32?
I do not have the YaRG API running on the ESP32. I have it running. Basically, it's running on a machine that is on the same network, because it also, the ESP32 has many problems. I could not get HTTPS to work. So like any endpoint that was going to require HTTPS somewhere just wasn't going to cut it, which a lot of the kind of like proxying through Tailscale or through like whatever, like all kind of relies on, like it never wants you to use anything but HTTPS. It's like, well, look, it's actually really difficult on an embedded device to make that work reliably. So yeah, the scenario right now is that if you've got a device that you want to participate in this ecosystem that cannot run something like YaRG API, which is not actually a difficult thing to run. Like it runs fine on like the weakest Raspberry Pi, but it's just not going to run on ESP32 because it doesn't have an operating system. It's just not enough memory the way it's written. So,
two questions. One is the solid arrow from web browser to YaRG API versus the pull dotted arrow to YaRG GDS. So the difference is the web browser can, so if you're directly talking to the API, you can force it to do things like move forward 100 or something. But if you post it on YaRG GDS, it's kind of like a suggestion that the rover may or may not take, right? Is that
exactly?
The difference?
It's sort of up to the rover whether it's going to pull it down, and you get no. The other problem, which is just really room for improvement, is that like besides the fact that the pending thing went away, like this flag, that one went away pretty fast. That's simply controlled by like did I detect anybody come and pick up those commands? But you have no idea, like, did it work? Did it not work? Like, there's really no feedback mechanism other than you can see this thing. I think this actually starts to turn red if it gets disconnected for too long. Like their codes are supposed to like tell you stuff about whether it's working or not. And the rover that this is controlling is actually turned off. However, since the YaRG API itself is running on my laptop, it still thinks it's alive, which is kind of, an interesting side effect. But if I do this, if I kill this, I think it starts to tell me after a certain amount of time that it just doesn't receive this sort of second sense boot kind of heartbeat.
And there'll be just one YaRG GDS, but there can be multiple YaRG APIs for multiple rovers. So eventually this will have like choose a rover and then publish a suggestion to it, something like that.
And to that point, let's actually switch over to a different one. So YaRG Prime, this is operating down by the Space Needle, by the way. If I put this Space Needle right there, there we go.
Wow.
So I just put in. So this is a simulator, and this is connected to a completely simulated rover that's also like written in Python, runs on a VM somewhere else, and that simulated rover looks like. Well, I'll pull this back. It's got its own instance of YaRG API. It's got its own like CI system, and then everything else is this like simulator program that like takes in motor control and then tries to keep an internal map of like where it thinks it is and which way it's heading, and makes up like sensor data that it can publish back. And that is, let's see, this thing, Rover Sim. I think we went back when we were talking about simulators, like a year ago or something. I think I talked about this maybe a little bit, and that's just like a really super straightforward simulator. But it's got the same. So let me pull up the components that are running for this are like the CI system is the script, which is we already kind of looked at, where it's just subscribing to the CI channel, which is what it's seen from YaRG GDS, and then it's translating those into motor signals, and then the simulator itself runs over here, and it's subscribing to the only inputs to its world that it cares about are, did someone tell me to run my motors? And so those will be events that it relies on, and then at the end of processing those events, it like sends this telemetry chunk, and those are then I'm not going to go through the entire code base of the simulator itself, but
wait, something I might have not understood. Mm-hmm. The simulator act is one of the rovers?
Yes.
Okay. And the YaRG API is run in the simulator, or how do you do that?
It's run in the simulator. So this is actually, so YaRG Prime is its own computer.
Mm-hmm.
It's got, a couple cores, and it's running Tailscale on it, and the editor that I just had open, and then it's...
And Gazebo, for example.
And it's running this YaRG API server on there.
Right.
And what else have I got running on there? Oh, so I was subscribing to the motor so that I could see that. But yeah, so it's got the YaRG API server running on there, and then over here in Docker, it's actually running the simulator itself and the CI component. So that kind of covers everything in that diagram. And then YaRG API on this server is configured to communicate with YaRG GDS, so it can pick up those commands.
If it's in Python, the Coppelia Sim has a Python scripting internal, so you can attach scripts to the robots inside the simulator, and basically you could attach this Python script to any robot you want inside Coppelia Sim. So that way we could run a simulator, basically
like a real simulator.
Yes.
Yeah. I think like as much as I didn't want it to be in a world where I was writing Python for everything, it became clear that like that seems to be the API for many of
Okay, I
these
can
things.
try to look into making a small caster wheel robot like Tumbler inside. I think it should have some models already in the Coppelia sim, and then we can try to attach the Python script
Yeah,
to that robot.
let's see if this actually works. Come on, map, move. Yeah. So I can drive my simulated rover around on this map.
What if I want to also have, simulated just for the image? Is that possible?
So this map thing is purely like going based on latitude, longitude.
Mm-hmm.
Something I think is wrong with my math, because I don't think that heading and that movement, I don't think that's right. I don't know. The simulator needs work or replace something else. So this interface, as you saw in the other example, it does handle image data. However, I never really figured out, a really easy way to make that work for the simulator to like take pictures of stuff. However, I started working on how imaging data ought to work with this system, because like I said, I kind of rebuilt a lot of the internals. Previously, if you wanted a photo, it would be like run this command, or look for an image at this place on disk. That was sort of like the interface, like pick up a still image, which doesn't really support video super well. So so you may have seen the web browser also has this arrow that's pointing at YaRG API here, and that's because I've got a kind of interactive, or not interactive, but a feed to see the data that's coming through. And so I think I will try to do a full real rover moving around kind of demo. I need to restart. This one. Yeah, I can see sending data through. And then, oh, hey, all right. All right, so I'll put this guy down. What did we use for emission last time? A baby Yoda?
Yeah. Blocking the exit.
Yeah. And does that show up? Oh, super dark, huh? Yeah, you can kind of see it.
Yeah, I can see.
Let me see if I can.
Yeah.
There we go. Okay, and so if we come back over here to YaRG GDS, go back to the other missions, garage demo. Oh, and so now it's running on battery power, and this information is all like actually correct. And so this is using that PCB that I made. The one neat feature on it was that I used like a voltage splitter sensor thing to be able to pull the voltage off of the battery, so I can see when it's running low or not. And so it's running at 6.2 volts, which is kind of right on the money. Will this work or will it fail? And this is where I was pretty sure that I messed up some things. So, oh, I am not. That's the problem. So CI wasn't running. Okay, let's try this. Oh, and the other thing I can do is, so I can come in here and we can do pub motor A, and I should be able to turn it on Yeah. And then let's go back over here. It's super dark, but it's going in circles.
You know, it's interesting. The frame rate is too slow for your movement speed. So you're saying it's going in circles, but it's, you know, there's no smooth view.
Yeah. Yeah, it's the frame rate is like 2 frames a second, I think. Also, the camera being mounted there isn't super great.
Yeah.
Yeah, and then okay, so that's like directly interacting with the motor control. But assuming that the CI thing is working, I should be able to come up over here and then let's do left turn 90. There we go. Well, it wasn't quite 90, but
Yeah.
yeah. So it's pointed almost. Oh, there's the doll.
So just I'm putting a pause here for a second.
Yeah.
Venkat, we were talking about what can we do, which is of interest. I think this issue of coordinating the task, the rate of feedback, the quality of feedback, and the communication bandwidth, so that the feeling is good for the controller. Whether the controller is human or machine, it's probably different. That could be something that we could work on.
Can you elaborate?
We were looking for something practical that we could work on, you know, as a group that relates to all of this. And what I'm saying is, when you have a rover and you have narrow communication and it has a mission, and really depends what the mission is, at what rate and at what quality do you send the images, as so that the whole system can work? Because obviously, if we increase the image rate, it interferes with everything else the system is doing. So it's not an optimization problem. It's much more complicated than that, because it's continuously changing. In fact, maybe it's even a policy problem. How do you set what these things should be? And it could even be different if the control of this rover is by RET or by RET's little pocket LLM. I'm just saying
The differences be.
it's an interesting problem. That's all I'm saying. It's not forward-looking. It's focused on a very particular issue, but it's real.
I just asked ChatGPT to explain RET's repo to me in like basic terms.
Okay.
Yeah, I think it's interesting to identify where this could go in terms of problems, like you said. But I think before we get there, it might be interesting to like find next steps that we can do starting from where RET is, and like just build up some enhancements to the point where it's sort of like kind of functioning as a team code base, and also connect the dots to what Anuraj is doing. Like
There is a lot of
examples
common thing already.
Yeah.
We are kind of doing the same thing, except that I have it in a frame and a gate.
I think what would be interesting, and like I was thinking about this while you were doing your piece of like, I think this could fit into the system somehow, and I wasn't quite sure how. I don't have an example of this, but I think it would make sense to, or at least it'd be a possibility, to be able to do things like have other interfaces, a frame interface that, or whatever, that like something else could be talking to, and it is talking.
Is that where you're
and
putting
it's
it?
talking to YaRG API. Yeah.
Is that where you're putting the frame interface?
I don't know.
I would have thought it would be outside of that dotted line.
Yeah, at least in my implementation, it's outside. So it's basically running independently, and then it forwards it to the chosen rover.
Yeah, the frame server
is actually equivalent then to like the
Yeah,
YaRG.
that's what it sounds similar to me as. So sounds like a useful common building block to build would be whatever is in the large dotted rectangle. So a standard representation of a rover that you can talk to, in this case, from like 3 different modes: regular web browser interface, a frame interface, and this YaRG GDS kind of like public lazy interface or something. So
and I've got another interface that it's actually built into YaRG API right now, but I don't think it should be. But it's the SunFounder the interface for the SunFounder iOS app.
Yep.
You remember that?
No, I'm sorry. What is
that? Actually, let's really tempt the demo gods here. Hold on. Come on now. There we go. So this thing, how do I have this set up?
Wait, you're emulating the iPad or iPhone app?
This is mirroring my phone.
Oh, it's mirroring. Okay.
Is this actually working? Hold on. Well, anyway, so this thing communicates via a web interface, and I added an interface to it on top of YaRG API. I don't think it belongs there. I think it belongs as like a separate component, and then each of these controls, this is how it works now. Each of these controls is its own like data stream. So like it's constantly posting 56, 56, 56 to channel K. And then this button is publishing to channel N. And so then you can like get this data into the YaRG API ecosystem. And then you can write some equivalent to CI that is saying like, well, I'm going to take data that I see on stream K, and I'm going to turn that into motor information for motor A, or you can connect however you want up in Python.
Right. So in your block diagram, this interface to the SunFounder would be equivalent to the web browser or something like that?
Yeah, exactly. So it would be over here.
Okay, and it would be publishing a stream of commands that the rover is required to follow.
Yep.
So another okay.
And then and then you'd need some other component in here that was like some founder adapter.
Okay.
That would read that raw data.
I'm a little sleep deprived, which is probably a good headspace to try and react to this, because if I can understand this in my current state, it means it's sufficiently simple. But one thing that strikes me about the big dotted rectangle is it has 2 types of components. One, a type of component I would call a body, and another I would call the head. So when you were talking about like a simulated rover versus a real rover, and Anuraj was talking about can this sort of like plug into something that's in Coppelia Sim, all that talk made me think that maybe head and body should be separated. So YaRG API, CI, Sunfounder adapter, these types of elements sound like they belong in the head that talks to the command interface type things. And then the body consists of things like camera, motor control, and all those things that are very dumb. So they talk to the head, and the head talks to, well, external command interfaces. Like even if you don't make that separation, is that separation logical, like head and body? Because then the body can be
I think that YaRG API is essentially the spine.
The spine, okay.
But it also has some head components that maybe isn't appropriate. And every time I find those, I'm like, maybe that shouldn't be there.
So the reason I'm asking is, like, suppose we run an experiment with, I don't know, 10 copies of your simulated rover running in different latitude and longitude, exactly the same you're running in the Space Needle. Now we have a fleet of like simulated rovers. It seems to me a logical next step would be to say, all right, let's plug half of those simulations into Coppelia so that they map to somewhat more realistic simulations. And the other half, maybe we just like map them to real rovers in real places. So now you're like treating them as stubs of rovers that then get expanded out, which is why I'm thinking they sound like heads that then connect to bodies. And the bodies can be either richer simulations or physical rovers.
The other thing that YaRG API sort of started off as is you're probably right that it's like this is both the head and the spine in some way, because it has the sense of identity sort of built into it as like a communication mechanism, if only to be able to say like this is what rover this is. Because if I actually, I'll just show it now. Back here in the repo, like the very first thing that it does is it shows like this is the project. It get the name of the rover. This would actually be on Prime. Let me show you that.
Okay, that fits the head metaphor, though. The identity typically goes with the head, right? Because if one rover breaks, the head can attach itself to a different body.
If it only has one brain,
Agent Smith in the Matrix, remember? He keeps jumping from body to body, taking control of different humans, right? So the YaRG API is basically Agent Smith, and the other physical stuff is the bodies he jumps into.
Yeah, I think I forgot to configure some of this. What was the environment? I don't even know how to use the software. YaRG API name. That's what I'm missing. YaRG Prime.
So it's running as a system service.
Yeah. Yeah. Okay. So then if you like curl the API of the rover, and note that this is running on like actually, yeah, this would be more interesting if you show it from my laptop. Okay, so this is running on my laptop, and if I do curl scale status, what is the name of this thing? Yeah, Prime. I guess I'll work. I can just curl this as just a host on the network, and it tells me its name is YaRG Prime. And if I had it set up right, it would show me like the link to the project that described it. So it's sort of trying to provide this like directory into what it is to be a rover. And it's also got endpoints like metrics that tells you this can be plugged into other, this is Prometheus, which is like a standard kind of for sharing telemetry data from applications into like dashboards and that kind of stuff.
And all this is running on the same tailnet, so there are no authentication type issues. Everybody trusts everybody in this something.
Yeah, although, well, we're really getting into it now. YaRG GDS is also running on a tailnet, and you can see that it knows who I am. Like it's got my picture up there, and scroll down to the bottom, it sees that I'm signed in as Rhett G. Oh, that's good. Signed in as Rhett G. It's actually using Tailscale has this method of like you can authenticate who the person is based on like their IP address because they're on the telnet and provide that authentication. So you can kind of tell like who it is by virtue of being on the network.
Okay, a couple more details I think I'm still a little foggy on. So YaRG API is talking to web browser and GDS through over HTTP and sockets. How is it talking to motor and camera? Is that on the same device? It's like talking locally, or is that also over sockets?
So in theory, it could be on a separate device because it's all the communication is still happening over web requests. Everything's web requests, and so theoretically, it can actually happen from anywhere that you can maintain a TCP IP connection to it. So like for my physical rover that's only an ESP32, only one of these boxes is actually running on the rover, sort of this one, and it's connecting to this one over the network, trying to create this kind of a virtual rover where it's not all running in the same place. Yeah, it's like it's not smart enough to be the whole rover all by itself, so part of it's been offloaded to my laptop.
Okay, so it's the dotted line is a logically defined rover spread across at least 3 physical things.
Yes.
Okay.
Or at least, well, this one, yeah, two, I suppose.
Okay.
Yeah.
Okay, that makes sense.
And you could imagine, like, our original Yakusaur design, which had sort of the big brain, little brain separation. You could imagine, like, a whole chunk of this ecosystem runs on the big brain, and the little brain is actually just one of these pieces. And when it decides to wake up the Raspberry Pi or whatever the big brain is, and it'll wake it up, and then it can communicate and like make use of all the other components, shut it down, save power, that kind of thing.
So in the scheme you have now, YaRG API needs a map of the whole topology with the correct addresses of ports and stuff in order to construct this virtual rover, right? It needs to know that the motor is on like some port, that kind of thing.
No, it's the other way around. That's why most of the arrows are all pointing to YaRG API. All they need to know is that YaRG API exists, which is why back over here on my simulator, as Anuraj pointed out or noticed, it is a that's the wrong one. No, that's right. It's a system service. That's running just like globally. That's the one thing, and then everything else is either running like a Docker container or it can run like any kind of number of ways. Really, the YaRG API is like once that's running on your system, everything else can run however you want it to run.
No, but if we have the Raspberry Pi, if you want to turn it off, then we can't, right?
Well, you could, but you wouldn't be able to communicate, or nothing would be able to communicate with it, right? It's like you would be, I mean, you're shutting off your big brain. Like the YaRG API is the big brain coordinator.
Okay, now I'm beginning to see a more immediate, like interesting problem, which is you've got a bunch of like as dumb as possible components. So like a motor attached to some computer and a camera attached to some computer. What would be the most sensible way for them to kind of like discover that YaRG API exists, or if there are like 2 competing things trying to be YaRG API, discovering that 2 of them exist and like picking one to like I don't know, connect itself to and become part of that synthetic or virtual rover, right? So there's maybe 2 cameras and 4 motors, and they all decide collectively we are going to go attach ourselves to this API, and therefore we now become part of the virtual rover, something like that. It's like bottom-up discovery by the rover of who it is by sort of like exploring what's available, or top-down, the YaRG API simply declares, hey, you're with me. So there's like a couple of interesting ways to like get at this problem, I think. Like how does
and that's I think that problem is probably why I honestly I barely remember because it was like a year and a half ago or something. But like this resources thing that it sort of advertises, like YaRG API is trying to advertise the services that it has available to act as some sort of discovery mechanism. Like if someone went around looking for rovers on the network, it could like pull and this endpoint and see like, hey, is there a rover there? What is it? What is it doing? What can it offer me? that was, I think, sort of the idea for that, because we were talking a lot about, I think at the time, about like different rovers having different capabilities that it could advertise to share with other rovers, with people.
But in the way it's currently set up, the motor can't simply say, "Hey, I don't want to work for you," and just not be part of the API.
Well, I guess
has-
it could, but yeah, it'd be very confusing.
Yeah,
As if it's all on a network, the motor could just decide if it got access to the network. It could just be someone else's motor.
Let's
Yeah.
flip the question. Instead of saying I want to go home and stop working, how does one of these components say, "Hello, I'm here.
Yeah.
I'm available"? Is it part of the API?
Not strictly. I mean, I guess it would depend on what that communication looked like. Like generally, how these, like the ones that I've played with so far, how they work is that they connect to a YaRG API and they say, "Give me data named motor A. Like if you have any data that's marked for motor A, just send it to me." You could imagine there being also a stream that's like, "Announce yourself." And so if every component said, "I'll connect to the topic called announce and I'll put my name in there," and then everyone will know that I'm there.
So this might be a good place to copy crypto type patterns. When a new node joins a crypto type network, how does it sort of announce itself and join the rest of the nodes and, I don't know, start participating
So
in a
there are protocols like P2P protocols, and there is one more protocol that is used on the consensus layer. So basically, we could adopt one of them, or like basically, if you have a node running, then this advertisement happens.
Because I think if we do this right, this becomes a very powerful abstraction. Like it's not just like you plug in a new camera and the camera advertises itself and attaches itself to the local API. It can be as much as like, there's like a bunch of rovers around and they can assemble to form like a formation of rovers that act as a single rover, right? Like you have two rovers, one of them is running the YaRG API, the other one connects to it and say, "Hey, I'm just going to like connect to you as a servant and follow you around." So now it's like more than just a camera or an actuator. It's like an entire other thing. So
I was kind of wondering if it would be ultimately useful to say like, if you had two, how do I zoom? There we go. If like having YaRG APIs connect to each other. Oh, what did I do? Having like some built-in mechanism to where certain streams get like replicated to another rover if so desired.
Yeah, like mirroring kind of thing. It's like just
mirroring some stream.
Yeah.
But in your current architecture, you're imagining that every rover will be running every physical rover. So physically co-located and like physically connected set of components, which we can call a physical rover. Each such assembly will be running one instance of YaRG API. So that'll be its head. Something like that is what you're imagining. Okay.
Yeah.
Well, I have another question going generally in this direction. What about negotiation? Okay, so I'm joining, but unlike a node in I don't know how it works in crypto, but when a node joins, everybody knows what it's supposed to do. But here, a robot joins and says, hey, I only work on Sundays. Okay, and then a different node joins and say, I only work if he doesn't work. So again, the question is, does this API support, or can we add a channel to support not only announcements but also negotiations? And you tell me forward 100, and I say no, there's a Yoda there. You want me to go forward? Pay me.
I mean, I think it just comes down to the software piece that you're right. But like communication mechanism, I think is clear. It would just be like, here's a channel. Instead of, you wouldn't want to have a channel that's like motor A is not negotiable, right? It's like go or don't go. But you could have another channel that's like, I don't know,
no, wait.
motor A request.
Well, what do you mean? What do you mean? Are you telling me that some GDS sitting in Seattle is going to tell a rover on Mars move forward, even though it sees a crater in front of it?
If well, no, it's going to say move forward. The rover's own command system, which my examples are all very simplistic. It just translates them into exactly what the motor should do. This command injection system could, of course, do other things like, well, I could read from GPS and my hazard map and determine if there's like a reason I shouldn't go over there. You could do all kinds of stuff.
And then what would it tell the GDS?
I mean, right now there's no back channel. Like, here's the result of, like, I think I mentioned that there's like no result of your command. Like, you send it off into the void, or you have posted it up there, allowing the rover, any rover, honestly, to come take it. And if any rover took that command, you don't find out anything about it.
I think the direct web browser interface is the better thing to talk about here, since that has expectations and it's also two-way or whatever. YaRG GDS sounds more like a very simple marketplace. It's like, I'm posting this job here. If somebody wants to do it. And the simplest addition I can think of making
tell me about it.
Some kind of semaphore return signal, which says that, okay, I picked the command number 3 that you posted, and that's done now. So it can like have that kind of very simple feedback. But the more direct command channel, I think, would be something like, direct web browser expecting to have full control of the rover says move forward 100. That goes into the command injector that detects this conflict you're talking about. That tells YaRG API, no, it's run into a constraint. And then YaRG API should tell the web browser blocking constraint or whatever the UI version of that propagation is.
Well,
signaling system seems, very
no,
flexible.
I'm liking what you're saying, but remember, I have to tell you that I'm taking the task. Then I have to tell you that I'm managing to do it, and then I have to give you the results. And all of these things take time, a random amount of time. Okay, we have time delays all over the place, not only because when it, on Mars, but also because actually doing the task takes time. So
and these are all running over async, kind of like soft real-time links, right? None of it
and
is.
You have, and a very real scenario of the rover could have actually rebooted and forgot what it was doing.
Okay, so
actually
it happens more often than you'd like.
An interesting basic design commitment we could make is this is only going to run in extremely soft real time, where the only thing commanders or GDS type things can expect is something like maybe sequencing constraints. If I issue command 1 and command 2, the only thing I can expect is that if command 1 happens and command 2 happens, they'll happen in that order, something like that. But even that.
Well, you can also ask for something to happen at a specific time, and it'll say, yeah, I'll do it at that time. And then maybe it'll happen, and maybe it doesn't because they rebooted and forgot everything.
That would actually be very interesting. Yeah.
Perseverance has some kind of autonomy like that. So basically, the NASA people are like give higher level commands, and then the rover kind of decides where it goes.
Yeah. All right, I'm getting sleepy. This is very cool revival of year-old thread of work.
I think I can call these pieces all somewhat finished and that they all connected together. And now only if I have rover problems that I want to actually like expand on it, I can. But it was a long time, and like, hey, I have this idea of how these can connect together, and they weren't for a year.
Yeah, maybe one thing we can discuss in one of the coming sessions is how to like unify this with the forecasted frames thing, because that might be.
Yeah, I will have to go through Red's code and then try to understand how it's working.
Yeah. ChatGPT just explained it a little bit to me. I'll have to go read that more carefully and try and understand what happens.
Which is convenient since ChatGPT wrote a lot of it.
That's good. All right.
Okay.
All
Then.
right.
See you.
We're back to
Cool.
actually
Catch y'all
doing
later.
things.